vehicle, but given the technology at the time, it did remarkably well. Flying over 100 missions. But of course, we had some accidents. We first had the Challenger accident in 1986 that blew up, killing 7 astronauts. And then right below, you look at the Columbia that accident that killed 7 astronauts too. So it's dangerous. It's dangerous going into space. It's very challenging at the same time, but that's how we learn and grow as human beings. Let me talk about current human spaceflight programs. The first one right now is, of course, space station that's orbiting up there, very large, 300 feet in length. It has a whole bunch of experiments on there, 14 to 16 different 14 to 16 international countries are working with the United States in operating the space station. We're learning about the microgravity environment, not zero gravity, it's called microgravity, to conduct experiments. There you see what looks like a match, lit on the ground. You can see the flame going up, but that same flame in space has a curvature to it. And of course, that's related to the gravity and what we call convection airflow. And then, we're conducting technology experiments. There you see one astronaut working in a glove box doing some experiments, and they're trying to understand how can we build better glove boxes and technology for looking at specimens that maybe one day we'll capture in Mars and look at them in a glove box. And of course, we're conducting, this is a big one, conducting human behavior and health experiments. There's Scott Kelly. He was there for over a year. And of course, he had a lot of issues afterwards. Our bodies are not meant for the microgravity environment. And so a lot of things happen when you're in space and you're in a floating environment. For one thing, if you got sinus drainage, it doesn't. You don't get that in the microgravity environment because your sinus cannot drain. So what happens is those fluids build up in your head, and that's why you see sometimes astronauts' head look very swollen. It's because there's no sinus drain. Other things that happen is the eye changes. The physical dimensions of the eye starts to change. The blood flow changes. Their heart becomes weaker. So there's a lot, and then of course they lose calcium in their bones, and their bones become very brittle, and it can be an issue. They're there for a long period of time, and that's why they exercise. Now let's talk about the commercial crew program. That's one that I've been involved with. This is the first time we've ever had a commercial space program, at least in the United States. It's opening a new world in commercialization of space, provide transportation to the space station. And we got partners in the Artemis program. And I'll say a little bit more about Artemis later, but there you see a picture of the Dragon space capsule and also the Boeing CST-100. And of course, right now, these two companies are competing for sending astronauts to space station. And right now, SpaceX is the winner so far because the Demo 2, which we just successfully docked.
Excuse me, sir. Someone is
Samir
presenting
Kumar.
their screen,
Yes,
and it is
Samir Kumar is presenting the screen.
Yes, sir. Many childs
Yes,
are
sir.
presenting continuously.
Okay. Yeah, somebody still has their mic on.
Again and again.
So here's the Demo 2 getting ready to dock with space station, and then down here you see the displays that the astronauts use. These were touchscreen displays. That was the main area that I was involved with SpaceX, is development of those touchscreens. And of course, right now SpaceX is competing for landing spacecrafts on the moon and sending supplies to the moon as part of the Artemis program, which is our next major program for NASA. And then you see a picture of a lunar lander by Blue Origin. So we got commercial companies competing now and building actual hardware that's going to go to the moon. So here's the Artemis program. So the Artemis program was like the Apollo program back in the 60s. In fact, Artemis was the twin sister of Apollo. If you ever read about Greek mythology. So, all right, I'm having trouble hearing because there's a lot of noise on the line, chat line. All right, so Artemis phase 1 is to go to the lunar surface by 2024. There's a lot of things that have to happen. First, we have to have the first humans spacecraft to go to the moon in the 21st century with people on there. And then we're going to be looking at things like solar electric propulsion systems. We're going to be looking at pressurized modules, the Gateway. Gateway is going to be kind of like the orbiting space station. And then we got human landing on the moon, and we're going to have people living and operating on the moon starting around 2024. So there's a lot of activity going on, lots of challenges, and not only the commercial partners. We got what we call the commercial lunar payload services, but we're obviously hoping, especially when we get to this point, that we have international participation. Perhaps even India would be participating here. We hope so, because it's going to take a lot of countries to make this happen. And of course, this is going to be the proving ground for Mars. One of the things about operations for deep space is going to be how we do things now. Right now, we got the space station, and we got a lot of people that support us on the space station. There's people in Mission Control Center in Houston, Texas, where I live. We got people in Moscow that are supporting the space station. Well over 200 to 300 people that are monitoring and watching the systems on space station. And of course, space station is complex. In the future, we're going to have a complicated spacecrafts orbiting the moon, and we're going to have some mission control, just like we have now, because it's only about a 1.5 second delay as far as the signal is concerned. But as we go further into space, like going to Mars, the time delays get worse and worse. And so something like the Mars transport that you see right here is going to be challenging. So instead of what we have in mission control with a whole bunch of people, we're going to have what's going to be called an onboard mission control, which is basically an artificial intelligent computer system that's going to help control and operate the spaceship. If you ever seen some sci-fi movies like 2001 Space Odyssey, that's what we're talking about, a HAL concept. But it's going to be complicated. There's a lot of challenges there. So we're going from crew mission control dependent type missions
Excuse me, sir.
crew vehicle dependent systems.
In the waiting room.
All right, so Mars systems, that's going to be major.
Excuse
That's
me,
going to
sir?
be major challenges right now. We're going from deep space testing to deep space validation. What does that mean? That means that we're going to have to make sure that these spaceships that go to Mars are going to be reliable, okay? Because we're going to have humans on there, and that's what we call it shakedown. Shakedown meaning let's make sure this thing works properly. If you've ever built something like, let's say, a tree house or your own bicycle, you always want to check it out before you take it for a long ride. Same thing with the spaceships going to Mars. We want to make sure that they're reliable before we actually put humans on there. And so we're going to have to land. One of the pictures, you can see this picture of a lander, okay, and landing on the Mars. And of course, Mars has a little bit of air. but not a whole lot. And the challenge is the size of the payloads, the size of the spaceships that are going to land on Mars are going to be big and they're going to be heavy. And it's going to be challenging to land something that huge on Mars. And so you see a picture here of a lander concept. And so these are going to be huge engines that require a lot of energy to slow down a spaceship that's very heavy. If you want to talk about mathematics and physics and science, it has to do with kinetic energy. So kinetic energy is 1/2 times the mass times the velocity squared. So if you're going at a certain speed and you have a certain mass, the kinetic energy just keeps going up and up. So you're trying to slow down that kinetic energy in order to land. Communications, that's going to be a biggie. We're going to have astronauts that are going to miss people back on Earth, and it's going to be a challenge, to communicate with their loved ones. And of course, living and operating on Mars, very challenging. So why send humans to Mars? And so, one of the things about humans is that we want to explore. We've always been wanting to explore. And so it's in our nature, it's in our blood, if you will. Driving technology, innovation on Earth and space. We can develop technology for space exploration that could help us here on Earth. The Apollo program was an example. For every dollar, American dollar, that was spent on the Apollo program, the return on that $1 was $7 in return from companies building new things using NASA technology. So space program is very beneficial. I know India has a program. India has the ISRO and Indian Space. I forget the organization. So you're going to see a lot of benefits from that space program. And of course, we want to see if there's life on other worlds, and it's the best choice for learning to colonize on space. It's close to Earth. Of course, you got to get past the asteroid belt and the Van Allen belt, which is highly radiation. There's warmth and light. There's length of day, very similar to Earth. Have seasons kind of like Earth. And there are some resources there, a little bit of atmosphere. There is water. There are metals. Okay, so we're going to have to learn how to live and operate there, and that's what the moon program is going to be all about. Physical needs. What are our needs for the moon and Mars? Well, physical needs. We need water, air, food, sunshine, exercise, clothing, habitats. You say habitats. Well, what is habitats? Habitats are very important for humans. Okay, if you live in a very crowded area, not good for the human, because humans like to have a little bit of space, to operate and work. So it can affect them physiologically and psychologically as well. And of course, staying healthy. Technology needs, they're going to need electricity. They're going to need materials to build things on another planet, tools, computers, vehicle, making fuel, robots, and everything must be highly reliable. Again, because of the psychology of how humans operate, it's important to make sure everything's reliable. Can you imagine living in another world, and you're afraid things are going to break down, especially like you're breathing air? Okay, if you're afraid that your air could break, the thing that provides air, imagine what happens to you in your head thinking about, oh my gosh, I'm here on the planet, away from home, away from my family, and this stuff is not operating properly. I could die any minute. And so this affects them psychologically with humans, and that's part of one of the things that I'm studying right now is the human element and how humans
some
behave.
children are there in the waiting
And
room.
then there's
Please let them in.
psychological needs. Isolation, safety, leadership, adaptation, and communication. So let me just briefly talk about complexity right here. Complexity is a thing that we have to deal with in the space program. Look at here's the example of the space shuttle, all the pieces that it had. Here's a picture of a diagram of some of the main elements of the space shuttle. But if you take the avionics system,
Some children are there in the waiting room. Please let them in.
so here's the command data handling system. If you break that down, one of the things, part of the command data handling system was a general purpose computer. Now, if you take, like, for example, the master event controller, it was you break that down and you got even more pieces, okay? So we're talking about lots of complexity on the shuttle. And so complexity and hazards can cause risk, but there's also hazards with human spaceflight. Not only hazards in the human system design, hazards with humans, but hazards lead to risk. And here's some of the factors that affect the human: the gravity effects, balance disorders, fluid shifts in the body, bone loss, space radiation can cause cancer. All right, isolation and confinement, being away from family members, behavior. Your humans behave differently when they're in isolation. The distance from Earth, it's going to be challenging to be away from Earth for a long period of time. And then, of course, a hostile environment. So, dealing with CO2 levels, toxics, of course, water, food, and then your immune system decreases. So here's an example of complexity. If you look at these pictures, you see that the more things that you have to work with, the more interaction happens. So for just two things, there's only one interaction, right? For three things, there's three interactions. But as you start getting bigger and bigger, the number of interactions is basically an equation such as this: n times n minus 1 divided by 2. So imagine something that has thousands of interactions. How many interactions engineers have to deal with in developing systems. So complexity, it can be a challenge, and something overlooked can cause a hazard.
Hello, Tommy. Hello.
Excuse me, sir.
Sir, some students want to join this meeting, but they can't join this meeting because you can't give them permission. Please give them permission, sir.
So the Apollo crew module, as I mentioned, we lost 3 people, and that was because of some complexity things that were overlooked. Basically, what happened was there was a piece of Teflon wire that was coated with Teflon, and of course, Teflon is very good for temperature, but not very good for handling wear and tear. And then Spaceship Two test flight, the system did not give a status to the pilot as to what was going on with something called feathering. And so because there was no status to the crew as to when to do feathering, they did it too early, and it caused the spaceship to crash. And we lost 1 pilot, and 1 pilot was severely injured. So let's talk about critical sciences for exploration. For the moon, we're talking about looking for water and understand further research that makes up the water on the moon. There's a lack of surface on the moon. So one of the things about the moon is that it has no atmosphere, and so it kind of preserves what happens to the moon as opposed to Earth. Earth, you got winds, you got tornadoes, you got cyclones and all kinds of things happening that changes the Earth. And so if things ever hit the Earth from outer space, it's hard to find because they've been washed away to the ocean or things like that. That's not the case on the moon. So because the moon pretty much preserves what has happened to that moon, we can find out what happened to the Earth many thousands of years and millions of years ago. Learn to live on another planet. That's going to be important. For Mars, there's the United States, tells you the size of the picture.
Excuse me, sir.
Okay. So I'm just going to give you a real quick overview of technology development landscape. There's a lot of things that have to be developed here in order for us to do all what we're doing. And so that's what we need we need partnership with countries, a lot of countries that can do different parts of it. We have challenges in science instruments, human health. How do we protect the humans? And then one of the things that's going to be very important is a machine called the Institute Resource Utilization. And basically, there's a lot here, but in essence, that's what's going to help us live off the land, because it'll convert the soil to water and maybe condition the soil so we can grow plants to eat. And in electronics, it's a major challenge because of galactic radiation. And so, on the ground, we got systems that, they don't care about power, but in space, because of the radiation effect, we have to deal with single event we have to deal with things that can destroy electronics. And so we have to be very careful, how we design that. So you can see there's a spacecraft card it's been developed, and so our computer systems are very, very small compared to the ones on Earth. Here's a room that you walk into. Basically, I talked a little bit about the history of spaceflight, human spaceflight, complexity, and deep space exploration. So just a few things for you guys to think about that I always do is, practice gratitude daily, thanking people, give back, become a mentor. That's why I enjoy doing this. It looks great on your resume too, as well, because it says a lot about your character. Get out of your comfort zone. You may find something new as a beginning, and grades don't measure how successful you'll be in the workforce. Your ability to take what you have, learn and adapt, innovate, and get along well. I was not a straight A student in high school, and I was definitely not a straight A student in college. Some of my friends were, but I can tell you that I did more things than some of the friends that had the high grade point average than I did. It's just a matter of what you have, and learn to use it. Learn to use it well. And the best tools, you don't need a fancy computer. For creativity, all you need is a cheap piece of paper, pencil, your imagination, a quiet environment, and you'd be amazed what you can come up with. So with that, I'm going to turn over control. There's still a lot of noise on the line, so I think we're going to use the chat window for questions. Oh my gosh, there's a whole bunch of things going on here. Let's see.
Sir, can you explain us about black hole?
All right. Can y'all write questions on the chat line? Now, I was in one webinar where the number of questions were controlled by the administrator. I don't know if you are doing that. If I get a whole bunch of questions, I'm not sure how to approach this, but right now I'm having a little bit of, I'm hearing a lot of noise on my end, and it's very difficult to hear what y'all are saying. So go ahead.
Okay.
All right, so
Excuse me, Mr. George.
Yes.
I've got a comment on your talk.
Okay, so I'm seeing questions about black holes. Okay. So, all right.
So, sir, firstly, can you just tell what's the motto of space exploration?
There's a whole bunch of noise on the lines. Wow.
Okay. Sir, explain about black hole.
I'm
Yeah.
okay. So I'm okay. I'm getting too many requests here, and I'm getting confused. All right.
Yeah.
We're gonna have to be a little bit more.
George,
Okay, George, hold on a minute. Okay. Guys,
right.
everybody on Google Meet, one question at a time, okay? One question at a time. Let Arnav moderate this discussion. Please raise your hand, put up one question, and it should be a meaningful question. Thank you very much. Arnav, go ahead.
Right. So it's great to meet you. What we can do now is we'll let the questions be posted on Google Meet, and then I can speak whichever ones that I feel will be appropriate, and you can answer those. Does that work?
Yeah, we could try it. Yeah, the only thing is the noise level. So, you know, if you number the questions like 1 point and then you know, say what the question is, that'll help. At least I know that it's coming from one person only.
Exactly. So I'll be telling you about the questions, and I think the correspondence can work this way. I'd like to request everyone else to kindly mute their mics so that you can just directly read from the chat. Right. So if I can just get 1 minute, the chat window. I think there are many questions. One of the common questions that are coming up are relating to black holes. So I think everyone wants to understand what exactly a black hole is. So like a short description.
Okay, so I'm not a scientist. I'm an engineer, but you know what I know about black holes. Obviously, is a star that eventually dies and collapses on itself due to the gravitational forces, and it becomes a black hole. And basically, the gravitational pull is so strong that not even light can escape. Though they're finding out that there's an element, and they're still doing some investigations on this, but there's an element that actually escapes, and so they're trying to understand what's going on here. So the beauty about science, what I love about science and engineering is that we're always discovering something new every day, and that's the part that's very I find that very fascinating for me.
And, I completely agree. And one of the most outstanding parts that I feel is science kind of predicts what is going to happen, and then we later can observe. So, for example, regarding black holes themselves, so the general theory of relativity already predicted what black holes would be, and then later we actually, we using data and everything, we actually validated that. So that is a pretty interesting way in which it works. So I'd just like to move on to the next question.
Go ahead.
Right, so it's just loading one second.
Excuse me, Mr. George.
Yes.
Sir, I've got a comment on your talk.
I'm sorry for that. Another question that has been coming up is related to Mars exploration. So one of the common questions here is why aren't we sending manned spacecraft to Mars? So what is the technicalities of it, and why space exploration in terms of humans is
Okay, so what's the question again?
The question would be why is NASA not sending humans into Mars?
So why is NASA not sending humans to Mars? At this point in time, we're not ready. There's a lot of things that have to happen. It's just not that simple. It's going to be just to go to Mars is going to take 9 months, and even though the technology is there to send spacecraft to Mars, of course, we've done that with Mars Science Laboratory. We've done with different Mars landers. But the thing is that it's the human, and that's why human exploration is expensive, because you have to protect the human. As I mentioned in my presentation, there's a lot of things related to the health of a human. going to Mars and coming back. You know, the radiation, we still don't know how to protect humans from radiation going to Mars. We still don't know how to design life support systems
Excuse me, sir.
that are very reliable. Okay, so I'm getting inputs from different sources now.
Sir, does alien exist?
All right, I'm getting a question about aliens exist. All right, so okay, so let me just say a few things about aliens. Okay.
Good morning.
All right. So I'm sorry. Let me finish the question because I'm
Please
running.
explain like a black hole.
All right. Okay, guys. I'm getting too many inputs, and I just I don't know which one to answer anymore. I got to get ready to go to a meeting here. So the only thing I can say is that I'm gonna have to. All right, guys.
We found
Last question, please.
like water and other, but
Okay.
why said that we
Sir, can I ask a question, sir?